Hello everyone, I am Mohammed. I'm studying computer science at the University of Texas at Arlington. In today's session, I'm going to go through some of the encoding techniques for data pre-processing for machine learning, and I'll be talking about how you can use some of the feature selection techniques and how you can use Pearson correlation in your data set. Let me go ahead and share my screen. Okay, I think it's visible now. Okay, so Um, here's the notebook. I have imported some of the libraries NumPy, Pandas, Seaborn, Matplotlib, and this is the dataset that I'm going to work on. I have given df.head to see the what columns I have for the dataset. We have person ID, gender, age, occupation, sleep duration, etc., etc. Then I'd given df of data types to see what kind of data type it is. So person ID, it's an integer, gender, it's an object. So there is like float and all this. Okay. df.shape to see how many rows and columns I have. df.isNull.sum to see if we have any missing values. If we have missing values, you have to take some extra measures for those. Then, okay. Then for the df.info, we can check like if there is a missing value or not on the data set. So we do that over here. So here on the data set, we can see for the sleep disorder, we're going to see how many unique values it contains. So we give that df sleep disorder dot value counts. So we can see there is like none. That value comes for 219 times. And sleep apnea, it's 78 times, insomnia 77 times. So these are the unique values for sleep disorder. Now, as you saw that this is a categorical data, right? So for regression, we cannot use categorical data in order to process our information. So what we need to do, it's like we can use some of the encoding techniques, or we can manually map those to make the categorical data appear as a numerical data. So here, what we have done is we did some mapping. So how mapping works is that I have set none to 0, sleep apnea to 1, and insomnia to 2. And I have called the sleep disorder again and used the map function in order to convert that to numerical data. And now when I do df again, and you see that, okay, sleep disorder, it's like it was in this form, string format, it's now gone. It's now convert into numerical data. Then I want to see the df occupation.value counts for all the unique values, and we are going to process it a bit later on this. So for mapping, there is one thing you should remember is that when there is like too many features, when there is like too many columns, and let's say the unique values, these are like there is like 20 unique values, right? So it's kind of not feasible to do mapping manually. So that's why we use the encoding techniques so that like we can automatically convert the categorical features into numerical. So this is one hot encoding. So this creates a binary column for each category and returns a sparse matrix or dense array depending on the sparse output parameter. So what is a sparse matrix? It's like the matrix that has more zeros rather than other numbers. So we are going to call the sklearn library, and we are going to call sklearn.preprocessing and import one hot encoder. We use the one hot encoder. I have created a variable here, ohi, for like short for one hot encoder, and drop first. So this is useful in situations where perfectly collinear features cause problems, such as when feeding the resulting data into an unregularized linear regression model. However, dropping one category breaks the symmetry of the original representation. So what I mean by that is basically, let's say we have this category, right? Gender, which is like both male and female. So let's go to gender here, male and female, right? So over here, when I give the drop first, it means that it would drop the first one, which is the male. It would drop the male category from the gender column. So what it would do is that, let's say the gender is male, right? So if I consider the male as 0 and female as 1, right? So when I'm dropping the male, I'm automatically telling that, okay, if male is 1, okay, wait. I think that does how, okay, wait. I need to go to this note. Okay. So here let's write something. Okay, where is the, sorry, I'm using this for the first time, so I'm still kind of not familiar with the how this thing works. But let's see. Hmm, where is the where is the pen? Um, okay, not this. Huh. Okay. Uh, I'm not really sure how this thing works, but let's see. Oh, there. Okay. So, okay. Let's say you have this Xander, right? So I would say Zen. Okay, this is very bad. Okay, so I have male and I have female, right? So when male is considered, let's say male is present, right? So we give it 1. Then female automatically becomes 0, because it's either male or female. So here, the one hot encoder, the drop first, what it's doing, it's dropping the male column and it's keeping the female one. So when you would see that female is 0, it means male is 1, right? Does that make sense? So here, this is exactly what's happening, that this is it returns an array of the gender column, and it gives you just one feature out of it. So here you'd see the array on here. So it won't work when you're trying, let's say here on gender, it's just male and female, right? When there is like more features, like let's say something like the occupation here, it has more features, right? So it won't work over here, because one hot encoding, it gives you a binary output. So it's either 0 or 1. If you're using more than that, one hot encoding won't work. So this is how we use one hot encoding. And then we give, I have created a variable here, Xender encoded bd.data frame. Then I have called this ohi dot fit transform. So I have called this over here, which is like I have put that in the variable AR. So I have called it. And then I have given the get featured names and Xender. So here, when I give Xender encoded dot index, df dot index, it actually stores those as an index, what the array. And then I have dropped the Xender column, because we have a new column right now, right here, which is like an array of just one feature. So I have to drop that. And now when I give df again, and you would see that, okay, there is like the Xender meal. Oh, okay, my bad. There is like some of the uh, columns aren't showing, so I need to load again. Just a second. Okay. Okay. Yeah. So yeah, here you can see that this is Xender meal. So um yes. I think there has been some problem in my data set. I should have also shown the Xender mail as a column over here. I should have printed, but that's fine for now. So you get the idea that the array that it creates over here, it's basically gets selected over here. in the whole data set as gender male, not like male and female both are there. So it's just gender male on there. Okay. So now we are going to use another encoding techniques, which is the label encoding. So here you can see. Before doing the label encoding, we need to deal with something else over here. So see, look at the blood pressure. It comes as a fraction, right? So even as a fraction, when you're trying to process the information, it would still count as a string, not as an object, not as an integer or a float. So we need to convert this into the integer format. So what I did is, also one more thing is important that you do some of the background checks to all the features that's available to the data set. So blood pressure, the numerator, it's called systolic, and the denominator, it's called the diastolic. So I have done that over here, like systolic, diastolic, and I have used the string dot split to split that. So it would split the numerator and denominator, and it would select the numerator as systolic and the denominator as diastolic. And here df systolic, so it would set the systolic part as an integer, and it would set the diastolic part as an integer over here. And then I'm going to drop the blood pressure column because now I have selected them as systolic and diastolic. So there is no point of blood pressure being existing on the actual data set. So I'm going to drop it. And then now I do df again, and you'd see that, okay, there is the systolic and there is diastolic. Now we do label encoding. So I have again, I have called the library sklearn and import the label encoder. So here I have imported them. And then here you can see that I'm going to do the label encoding to the occupation, this one, BMI category, and what else? Mm, and the sleep disorder. Okay. Oh no, actually it's not needed right now anymore because for sleep disorder, we have already done that for mapping. See? So it's already done. So we don't need to do it again because that would create redundancy over here. So when I did like manually mapping, it has already set the changes in the data set. So I don't need to do that again. So we are just going to perform label encoding on the occupation and the BMI category. So I have created an object here, LE label for label encoder. So I have called it. And then when I give, okay, I need to run these as well. Sorry. Um, here. Here, yeah. So now you can see that when I have given these over here and yeah, so now after calling the label encoder over here and fit transform, so I have converted all the occupation to the numerical values, and also the BMI category, it has also turned into the numerical value. So now it's ready for your for performing regression later on. Now, I'm going to do one thing because I need to create the independent and dependent features, right? So I'm going to make the X column as the X as it will be for the independent features, and Y it would be for the target feature. So basically, what it's saying is that sleep disorder, it will be dependent uh, um, on the basis of the X. So what I mean by that, that okay, quality of sleep, sleep duration, this would all have an effect on the sleep disorder because I'm going to perform an analysis depending on all the existing columns over here. And what I'm going to do is also drop the disorder column from the actual data set right now because the X it's different from the Y, so it cannot mix up together. So that's what I did. I'm going to run this again. So here, yes, when I give X, you can see that the sleep disorder, it's no more on there. And on the Y column, we have the sleep disorder back again. Okay, so that's so far for the encoding techniques. But one more encoding techniques that's really important, but it's right now, it's not in the data set. That is the ordinal encoding. So when ordinal encoding comes, it's basically when you are, let's say, working with some sort of ranking, right? Let's say you have a rank given. Let's say you have a roll number. So it's like one after another and it's ordered. So in that case, you cannot use these label encoding or one hot encoding. That time you have to use ordinal encoding, but that's a conversation for later on. So yeah, moving on. Now, how you do feature selection. So for feature selection, it's basically gives you a score. It gives you an output of score that would tell you that, okay, which of the columns are most important to affect the target variable. So that feature selection can be done with chi-square test, that can be done through ensemble learning. So let's try the chi-square test. So we import the library sklearn feature selection, import select kbase, kbest. So it would tell you that, okay, how many features we can select. So there is like so many, right? So it's your choice that you want to bring in like all of them or like a few of them. So it depends. Let's say some of the columns for like person ID, this one doesn't matter that much. So you can drop this one and you can bring in these ones, right? So you can select that through select kbase, and then from sklearn.feature selection import chi-square test. So now chi-square test, I need to go to the OneNote again to show you how this works. Okay. Okay. So let's say, hmm, I'm going to create a artificial data set. Let's say this is one is going to be Zender, right? Zender. And another one, it's going to be, let's say, what can I give? Um, let's say I give another. So this has to be categorical, right? So I give let's say age. Okay. So for gender, it would be either male, male, female. And for age, let's say, okay. Let me give one more. Male. Okay. And age would be, I'm sorry, my screen is not that visible. And age would be, let's say, mid-age. It would be mid, old. Let me just write down old for O for old, and then Y for young, and then old. Okay. So I have this artificial data set of categorical features. So here, we would have some of the factors, which is like hypothesis testing. So there is this, and then alpha less than 0.05. I'm sorry if my drawing is a little bad, but I hope it's understandable. Okay. Okay. So here we have two categorical features, right? Gender and age. So on here, when I'm dealing with, let's say I'm dealing with just this gender, this one column, forget about age for now. And I'm saying that, okay, what's the ratio of the male column to the, no, what's the ratio of male and female, right? So hypothesis, as in like, I'm going to make an assumption that the male ratio is equal to the female ratio, right? And then for there is going to be an opposite hypothesis or an alternative hypothesis, which is going to tell me that male ratio is not equal to female ratio. So basically, what I'm saying is that to find out that what kind of test you're going to apply, we need to come up with these assumptions first. So to understand this, right now, when I'm working with just the gender column, and we can say that, okay, the first hypothesis, the null hypothesis that comes to my mind is that, okay, what's the ratio of male ratio to female, right? And the alternative that exists, that, okay, how much male ratio is not equal to the female ratio. So over here, that's basically it's saying. And the alpha, it's the significance value of it. So when I have it less than 0.05, let's say, so okay, let's say there is a Gaussian distribution, right? And then this is minus 2.5, and this is 2.5. And here, what I'm saying is that 0.5, it means that it stays in the middle. So this is the 0.5, right? So here, when it's less than 0.05, we would reject the null hypothesis and we would accept the H1, which is like, no, the male ratio is not equal to the female ratio. So in that case, we would select H1. But if it's like greater than that, then it would be the null hypothesis, which is the H naught, and it says that, okay, male ratio is equal to the female ratio. But when I have so in that case, the test that we apply, it's called, so for test, it would be the one sample test, right? So it would be, I'm not writing it, but you'd get it that it's the one sample population test. So that's for when you're working with just one category of the columns. But when we have two categories, gender and age, and that time the hypothesis, the null hypothesis, it would change to this saying that what's the ratio of the gender column to the age column. So it would become G equals to A, just for like your understanding. Just think of it like that, that, okay, G is equal to A, and then the H1 becomes G is not equal to A, because the ratios are different, right? So on that case, when we select that, okay, what's the significance value? So if it's less than this, if it's less than 0.05, then we would say that, okay, we reject the H naught and we would accept the H1. But when it's greater than that, we would say that, okay, we accept the H naught, right? And that time, the test would be chi-square test. Chi-square test. Okay, so in this case, you have to also remember one thing, that when you're working with the significance value, it has to be selected before the test is done, not like after the test, because it's important that you find out that which hypothesis you're going to work on. So that's why. So this is the basic test, but for now, like, I'm going to skip that why, like, what is the chi-square test and how does it work, and what about the one sample test. Those are will be covered in another video. But for now, just select like how you know that it's going to be the chi-square test. It just gives you a gesture that, okay, when you should use it. Okay. Okay, let's go on to the notebook. So here you can see that we are going to be working with a lot of columns, like more than two columns that are categorical, right? So we have selected the chi-square test. So from sklearn.feature selection, import chi2, and then we're going to give it a rank, ordered rank features. So based on the select k base, we have two parameters that, okay, what's the basis of it, that the function is going to return an output, right? So it will have a score, right? So it will be based on the chi2, which is the chi-square test, and k is equals to 13. So it's the parameter that how many columns we're going to work with. So here we have the 13 columns, but it's your choice that if you don't want to work with some of the columns, you can like select, let's say 10 columns. That would also work. So over here, I have given that. And then the ordered feature, which is like ordered rank features that fit X and Y. And then now when I'm like printing it, and it would give you an array of the features here. See? So it gives you a rank over here. And then when I'm giving it that what's the length of it, because we have selected that k is equals to 13, and it's like 13 on here. So that, and then now I'm going to select a feature score, and this part, it's basically saying it's dividing that, okay, what are the features and what are the scores. So it would put you aside so you can see that, okay, what's the ranking behind it, that what are the columns that's affecting the target column like a lot. on the basis of the chi-square test. So here you can see that the person ID, then the age, then the occupation, these has already given a certain score, but it's not ordered yet. The ordered one, it's here, that daily steps. This one has the highest impact on the target label. So this is the daily step, then the person ID, then the physical activity level. So it shows you all that. See? So this is what the chi-square test is basically doing on there. But there is like one more testing technique, which is like ensemble learning. So how ensemble learning works, it's like basically, let's say in one data set, you want to implement like all the models, let's say like multiple models, let's say decision tree, SVM, and let's say like more kind of models. And on those models, what specific features based on the model, what specific features has an effect on the target label, ensemble learning would find those features and it would implement there to find the best features that has the impact, right? So ensemble learning, it's basically a way for you to find the best features from various columns altogether. And you have to import the extra trees classifier, a library. So it would basically would be used for mutual information based feature importance calculation. So it's like based on the given information, it would calculate that, okay, what's the importance of one particular feature? And then I'm going to fit it again on the XY. And then when I'm printing it, it gives you a value over here. See? So it has like some of the score kind of thing on here. And then I'm going to create a series of it because I want to visualize this. And when I'm creating it, and it says that over here, I'm going to create a plot. And now when I'm making it, see, here is the difference. Like here you can see that, okay, what are the columns that has the highest impact on the target label? So here the BMI category, then the person ID, those are the same, then diastolic, then systolic, and this, and so on, so on. See? So here, but if you try to match it up with the chi-square test, it won't, because it has a certain parameters that's different from the chi-square test. So it might give you a different alternative value, a different value to find the importance of each feature. Okay, now we're going to work on the last topic of the session for today, which is Pearson correlation. So now correlation means that when some columns, let's say some values that are no, actually correlation means that one column is related to another column. So what correlation does, it's like it creates biases on your model. So it would have an effect that um, on your results. So you don't want to introduce biases on your output. So that's why it's important that you drop them or drop the correlated features. So I have printed the df.correlation and it would give you a value, but we won't understand anything from here. We would need to create a heat map. So, but what we can get is that, okay, how many columns are correlated? So we would get that there is like 14 on here. So or maybe this is not correct. Okay, yeah, let's keep it for now. Yeah, we okay, so we need to identify the correlated features, right? So we would create a heat map over here. I have created this. On the heat map, you would see that if I zoom in, um over here you see that here is the sleep duration, right, which is like 0.81, and the stress level, this is also 0.81. So this is one of the correlated features. So here this correlated features, the stress level and sleep duration, if it stays like this, it will have a bias on the accuracy result. So we need to remove them from there. So how we are going to do it is that we would need to import the train test split from sklearn model selection, train test split, because we need to prevent from overfitting. Okay, I will give you a quick idea what's overfitting is. It's basically let's say you are training your model based on the trained data set, but there is another data set that's test data set to see that, okay, how it runs when there is like a new kind of thing that's there. let's say for train data set, you have you're able to identify a certain type of features, right? Like that's in already exist in the trained data set. But when there is some new kind of features, it's not able to find that, right? It's not able to detect. So on that case, we call it that overfitting, because like it's too much focused on the trained data set. So we are going to implement the train test split because of that, to prevent it from happening. And we're going to select that, okay, we're going to differentiate the train data set and the test data set. We would like cut that on there. So then I give like xtrain.shape, and here, so for the there is like I have already used the x and y, right? Like I have already separated them. X is like all the independent features, and y is the target feature. So here when I give xtrain.shape, it would give you the all the rows and columns that exist on there. I yes. And when I'm giving the X test, so it has like already separated the train dataset and the test dataset. So test is mostly used to see that, okay, how is your model performing? Then with the following function, we can select highly correlated features. It will remove the first feature that is correlated with anything other feature, right? So it's basically this function. If you go to the sklearn library, and you can find similar kind of functions already created there. So I have copy pasted it from there. So here what it's doing is takes X train data set. So here the data set, it's mostly focused, it will be set to the X train, not the X test. And the threshold is that how much percentage is correlated, right? So here on this data set, you can see this is almost 80% correlated, right? So you can set that threshold to your own convenience, and then call correlation a set. So it would create a set of the correlated columns, and then the correlation matrix. So dataset correlation. So it would basically traverse through all the correlated matrix that's there. So it would like iterate on there. So for I in range length of correlated matrix dot columns. So all the correlated features, it would go through them, and then it would return those like which the columns are correlated. It would return the name of the columns from there over here. So on here, one more thing is important, that this function is only applicable to the absolute value, right? So when you have a negative value here, it doesn't process that. But to do that, we need to create another function on there. But for now, we would just work with the absolute value ones, right? The features that are correlated. So now when I'm calling the correlated features over here, xtrain, and I'm selecting the threshold value. So xtrain, it's the data set. So as I told you, that the data set has to be applied under the xtrain data set, not the xtest, because it would automatically be applied on the xtest data set. So xtrain, and then I'm going to create the threshold value 80%. So you can give it like 0 0.7, 0 0.6, up to you. And then when I'm calling the length, so I would see that depending on the 80% of the correlated features, there is like 4 columns that are correlated on there. So when I'm giving it the correlate features, it would give you the names of it. So age, dash, solid quality, sleep, stress level. Let's have a look. Okay. Uh, age. Um, hmm. Okay, for now, even I cannot find it, but you get the idea, right? So it's like there is like so many values. So I need to compare and see that, okay, which are the values that are correlated on there. But it gives you like a general idea that these are the correlated features on there. So then I have to drop them. So because I have now created them from the like import train test split, so it's like separate data sets. So I need to drop all the correlated features from both of them, the X train and the X test. And you don't need to worry about the y, because y, it's basically just the dependent variable, right? So there is like no way of like having like correlated features on there. So you would drop it, and now your data set is ready uh, to use your required model that you would need to find the accuracy rate on there from this. And oh, one more thing I forgot to tell you. When you're doing the chi-square test, remember that it has to be like it cannot process any negative value. So if there is like a negative value present on your data set, you need to process it in order to apply the chi-square test. Okay, so that's it for today. I hope you have understand the techniques and you would find it helpful. So I'll be back with like more the advanced topics and the things that I couldn't cover in today's session. I would explain those in a later session. And thank you for joining my session. Have a good day.